Hi students, okay, today in this lecture we discussing the topic is Laplace transform. So this is one of the transform techniques. This transform techniques can use to solve differential equation with given initial condition. Okay, first of all see the definition of the given Laplace transformation. So let given function is f of t of function t for all defined t greater than or equal to 0, then the Laplace transformation of f of t is denoted by L of f of t or f of s and is defined as, so L of f of t is equal to f of s is equal to integration 0 to infinite e power minus ht into f of t dt. So L of f of t means, so given function f of t together. Now transform techniques, the Laplace transformation. So t is converted to a new variable s anamata. So this is f of s is Laplace transformation. So finding this integral is called Laplace transformation of the given function f of t. So a variable s is always greater than 0. So provide the integral exists where s is the real or complex number. Okay. So and sufficient condition for the existence of the Laplace transformation of a function. So this is one of the condition only. Ante when the Laplace transformation exists for given any function, so satisfy this condition, that is the Laplace transformation of a function exists for x greater than 0 if f of t must satisfy the following conditions. So that is, so f of t must be piecewise continuous in the finite interval. Second one, f of t is a function of exponential order. So when the given function satisfy the two properties, and then Laplace transformation exists for the given function f of t. Okay. Okay. See the two definitions here. Piecewise continuous function. So a function f of t is said to be piecewise continuous over closed interval a comma b if it is defined on that interval and is such that the interval can be divided into a finite number of subintervals. So in each of which f of t is continuous and has both right and left hand limits at every end point of the interval. And that means given function is continuous on the given interval, and when that interval can be divided into subintervals and any subintervals, then that function is must be continuous in every finite interval, and also there exists left hand limit and right hand limits. So that is called, the function is called piecewise continuous. And if interval ని మనం డివైడ్ చేసినప్పుడు కూడా that function is must be continuous at every point in subintervals. Okay na? So that is the definition of piecewise continuous. So this is one of the example here. So is piecewise continuous for t greater than 0. So because 0 to 5 interval and so 0 to 5 interval can be divided to subintervals 0 to 5 ఒకటి 5 to infinite ఒకటి. So for each two intervals 0 to 5 and 5 to infinite. So in two intervals the given function is continuous. Therefore this is piecewise continuous. So second example here, f of t is 1 by t is not piecewise continuous function in any interval containing 0. అంటే మనకి ఎనీ చూసింగ్ ఎనీ ఇంటర్వెల్ విత్ 0 అయింది అనుకోండి, ఎట్ ద పాయింట్ 0 ఈస్ not defined. So not defined means is not continuous. So that means is not piecewise continuous at point only 0. So next, function of exponential order. So a function f of t is said to function of exponential order a if limit t tends to infinite e power minus at into f of t is equal to a finite quantity. So for the given function the limit value exist కావాలండి మనకి for any a is any positive number. So if limit t tends to infinite e power minus at into f of t is equal, this value is మనకు finite quantity వస్తే that function is called exponential order. So see that example, t square is a function of exponential order అండి. for given any number that limit is exist, that is a finite quantity exists. So e power t square is not function of exponential order, because at any point e power t square the function value limit values there is no finite only. So then that is called not exponential order. Okay, this is a definition of piecewise continuous and function of exponential order. So next one. So this is the formulas for find Laplace transformation of the given function only. So first function 1 ki Laplace transformation 1 by s. So t ki Laplace transformation 1 by x square. So next to t power n, this is a function t power n, this and its Laplace transformation is n factorial by s power n plus 1. So next to t power n, ikkada n is a positive integer when it's not integer. So we have two formulas here, function of t power n ki Laplace transformation. So this is the first one. The second one is not integer enough, gamma n plus 1 by s power n plus 1. So next function e power at ki 1 by s minus a is the Laplace transformation. So sin at ki Laplace transformation a by s square plus a square. So cos at ki s by s square plus a square. Next sin hat, hyperbolic functions. So a by s square minus a square. Next cos hat, s by s square minus a square. This is the basics functions only. So these basics functions ki Laplace transformations are given by this one. So this is a very important formulas. In the problems anni kuda using these properties and okay na. So next one. So see the example here. So find the Laplace transformation of the given function e power at plus 4t cube minus 2 sin 3t plus 3 cos 3t. So assumption this function is f of t. So now applying Laplace transformation L on both sides. So that is equal to L of f of t is equal to L of so given function. Okay na. So this is a linear transformation and so Laplace transform applied to every function. Okay, that is equal to L of e power 2t plus 4 into L of t cube minus 2 into L of sin 3t plus 3 into L of cos 3t. Okay, so now using the basic formulas already told in the previous slide. So this is L of e power 2t kada ante e power at formula ikkada a is equal to 2. Okay, so that is equal to here 1 by s minus 2 plus 4 into ikkada L of t power n kada. So n ante ikkada 3 is a positive integer. మనకు 3 integer ఒక ఫార్ములా ఉంటుంది. మనకి ఏంటిది అది n factorial by s power n plus 1. ఓకేనా, n ప్లస్ లో 3. సో మైనస్ 2 ఇంటూ సైన్ ఆఫ్ 3t అంటే సైన్ ఆఫ్ 80 ఫార్ములా a by s square plus a square కదా, 3 by x square plus 3 square plus 3 into L of cos 3t cos 80. సో s by s square plus a square ఇక్కడ a is equal to 3 అండి. So using this basic formulas Laplace transformation, the now simplification is so 1 by s minus 2 plus 24 by s power 4 minus 6 by x square plus 9 plus 3s by h square plus 9. So this is a Laplace transformation of the given function. Okay, so next example. So find L of sin h 2t plus cos ht minus sin 4t into cos 2t. Okay, no? So that is equal to given problem, that is equal to separating Laplace transformation L of sin h 2t plus L of cos h 2t minus L of sin 4t into cos 2t. So that is equal, this is sin h at kada, a is equal to formula using so 2 by s square minus 2 square plus this is cos h at. So that is equal, a is equal 1 here, s by h square minus 1 square minus the product of the two functions kada manaki formula only one function f of t, adi sin at kavachu cos at kavachu edaina kavachu, but product of the two functions is converted to the only single function. So by using the formula, this is a sin a cos b form andi avuna. So there is no 2. So dividing multiply with 2, 1 by 2 into 2 into 2 sin A cos B form. That is equal to a 2 by s square minus 4 plus s by s square minus 1 minus 1 by 2. So now using the formula 2 sin A cos B is equal to sin A plus B plus sin A minus B. So now finding Laplace transformation. That is equal to 2 by s square minus 4 plus s by s square minus 1 by 2 into s by s square plus 6 square sin A t form. So 2 by s square plus 2 square. So this is a required Laplace transformation of the given function. Okay. So next one, find L of 1 plus 2t by root t. So L of 1 plus 2t by root t, denominator root t kada, separately dividing. So L of 1 by root t plus 2 into root t. So that is equal to here L of 1 by root t means that is t power minus 1 by 2. So this is 2 into t power 1 by 2. That is equal separate Laplace transformation L of t power minus 1 by 2 plus 2 into L of t power 1 by 2. So observing here t power minus 1 by 2. Minus 1 by 2 is a not integer here. So using the second formula Laplace transformation of t power n. So that is equal to here gamma n plus 1 by s power n plus 1 formula. N is equal to minus 1 by 2. So gamma minus 1 by 2 plus 1 by s power minus 1 by 2 plus 1 plus 2 into same gamma n 1 by 2 plus 1 by s power 1 by 2 plus 1. Now simplification gamma 1 by 2 by s power 1 by 2 plus 2 into so ఇక్కడ gamma n plus 1 అంటే 3 by 2 కదా. So by using the properties of gamma, so that is equal to 1 by 2 into gamma n ఇక్కడ formula gamma n plus 1 is equal formula n into gamma n అండి. So 1 by 2 into gamma 1 by 2 by s power 3 by 2. So that is equal gamma 1 by 2 value root 5 by root s plus, so you got 2 to cancel, root 5 by s power 3 by 2 means s into root s. That is equal root 5 by s is a common plus 1 by s. This is the required Laplace transformation of the given function. Next one, find the Laplace transformation of t square plus 1 whole square plus sine of at plus b. So that is equal to Laplace transformation of this one. So that is equal to L of t square plus 1 whole square plus L of sine at plus b. So this is a plus b whole square expand. Okay. That is equal to L of t power 4 plus 1 plus 2t square plus L of, this is sine a plus b form only. Sin at cos b plus cos at sin b. So separate Laplace transformation. This is t power n. N is a positive integer 4. 4 factorial by s power 5 plus L of 1 1 by s. So 2 into t square means 2 factorial by s cube. So ikkada cos b is a constant. So constant outside of Laplace transformation. Cos b into L of sin at plus ikkada sin b is a constant. Manaki function of t ki maatrame Laplace transform find out chestam. So without t, that is a constant sin b. Sin b is a constant L of cos at. That is equal to 24 by s power 5 plus 1 by s plus 4 by s cube plus cos b into L of sin at ante a by a square plus s square plus a square plus sin b into cos of at ki Laplace transformation s by s square plus a square. So there is a required so value. Okay now. So next one. So find the Laplace transformation of sine root t. This is an important question, long question. So there is no directly Laplace transformation of sine root t and ఎందుకంటే మనకి sin x ఫార్ములా ఉంది, sin at cos at కదా, బట్ root t ఇక్కడ t power 1 by 2. Okay, now there is no sin root t ki direct formula. So using the series of sin x form, sin x ki power series x minus x cube by 3 factorial plus x power 5 by 5 factorial minus up to so on. Using this infinite series of sin x and ఇప్పుడు x place లో root t replace చేయండి. So that is equal to sin root t is equal to root t minus root t whole cube by 3 factorial plus root t power 5 by 5 factorial minus up to so on. Now taking on both sides Laplace transformation. So L of sin root t is equal to L of t power 1 by 2 minus L of t power 3 by 2 by 3 factorial plus L of t power 5 by 2 by 5 factorial minus up to so on. Okay, now using the formula of Laplace transformation t power n, n is not integer, second formula. So that is equal to here gamma 1 by 2 plus 1 by s4 1 by 2 plus 1 minus 1 by 3 factorial is a common. So gamma 3 by 2 plus 1 by s4 3 by 2 plus 1 plus 1 by 5 factorial is the common. Gamma 5 by 2 plus 1 by s4 5 by 2 plus 1 minus up to so on. So here using the property of gamma. So gamma n plus 1 is equal n into gamma n kada. Okay na? 1 by 2 into gamma 1 by 2 by s4 3 by 2. Ikkada 1 by 3 factorial means 3 into 2 into 1. So gamma 3 by 2 plus 1 ante the simplification, that is n into gamma n kada. So that is 3 by 2 into gamma 3 by 2. Malli 3 by 2 malli em raskochu 1 by 2 plus 1. So again 1 by 2 common. 3 by 2 into 1 by 2 into gamma 1 by 2 by s4 5 plus similarly 5 factorial ante 5 into 4 into 3 into 2 into 1. ఇక్కడ 5 by 2 plus 1 అంటే 5 by 2 into gamma 5 by 2. సో మళ్ళీ ఎక్స్పాండ్ 5 by 2 అంటే 3 by 2 plus 1. 3 by 2 మళ్ళీ ఏం రాసుకుంటాం 1 by 2 plus 1 అవన్నీ కామన్. సో 5 by 2 3 by 2 1 by 2 gamma 1 by 2 by s power 7 by 2. So that is equal to simplification. Now here common gamma 1 by 2 into 1 by 2 is a common by s power 3 by 2. Okay na? So remaining term here 1 minus 1 by 4s by 1 factorial after simplification and all are simplification which is can be write in the form. First one term is the common 1. So remaining terms 1 by 4s by 1 factorial plus, so in this one remaining 1 by 4s whole square by 2 factorial minus up to so on. So which form here? ఎలా అని చెప్పండి 1 minus x by 1 factorial plus x square by 2 factorial minus up to so on. That is e power minus x expansion. So that is root pi. Gamma 1 by 2 అంటే root pi కదా. సో ఇక్కడ 1 by 2 into s power 3 by 2 అంటే s into root s. So this is the expansion of e power minus x. ఇక్కడ x place లో 1 by 4s. ఓకేనా? So this is the required value of the given function. Okay, this is important question. So next problem, find the Laplace transformation of the given function f of t. So f of t is ikkada given interval is 0 to infinity kada. So that is 0 to infinity can be divided into 3 sub intervals, that is 0 to 1, 1 to 4, 4 to infinite. So integration is also separating on each interval. So by definition, so this is a by definition Laplace transformation of the given function f of t. Okay, so that is equal, this is integration also dividing in 3 intervals 0 to 1, 1 to 4, 4 to infinite. That is equal 0 to 1 e power minus st into f of t. F of t is equal to the value 1. Is separating. So 0 to 1 e power minus st into f of t is equal to 1. First one, next 1 to 4 interval e power minus st into f of t is equal to e power t plus 4 to infinite f of t is equal to 0. Now simplification is, so first one 1, second one ikkada e power minus st into e power t, ikkada t common చేయండి పవర్ లో minus t common చేస్తే e power minus t into s minus 1 dt, this is the 0. Now integration, so e power minus st integration e power minus st by minus s 0 to 1 limits, ikkada e power minus t of s minus 1 by minus of s minus 1 1 to 4. Now simplification is e power minus s plus e power 0 1 minus of minus plus by s plus ikkada t plus లో 4 e power 4 into 1 minus s minus e power 1 minus s by 1 minus s. So this is the required Laplace transformation of the given function. So So this is one of the first topic, Laplace transformation, and with example. For more videos, please do subscribe my channel, like and share it. Thank you.